Alright, so as promised, I said that I would make a video about this. Last time in class we talked about a couple of different things. I asked you to compare the difference between this, x times x times x, and the difference between that and x plus x plus x. And in class, we determined that when we are multiplying things together, it ends up being that value. So we have x, we have three x's, and we decided that that would be x to the power of 3. And so when we multiply things together, when we have multiplication, that raises the power to that many. And then we came and we determined that x plus x plus x, there are three of them, that the difference between the multiplication and the addition was that the number ended up in front instead. And then I asked you to do this problem. And I said, I really want you to represent 3x times x in an expanded form. So we've got the big expanded form, and we have the condensed form, the expanded form of an exponent and the condensed form of the exponent. So I asked you to do that with this particular problem, and I hope that you can see that if I have 3x right here, that 3x is the same as that 3x. So I'm going to do that. I will go ahead and highlight this 3x there, and that's the same as this 3x right here. And so we're going to just go in and replace it. So 3x is x plus x plus x. We'll close that. And then this x is going to come down right in front, and it's going to be multiplied by x. And so I'll hopefully be able to do that with a highlighter as well. That x is still just that x right there. So you can see the difference between those two things. Well then, I said, hey, if we have this, and we talked a lot in class about area, and I'm going to go ahead and off to the side here, I'm going to do something completely separate. I'm going to go over here and I'll show you. Remember we had two boxes, and we started to decide that if I have 3 and 12, that the area was 36, and that could represent a multiplication problem. 3 times 12 is 36, or is equivalent to 36. By really talking about area, and we talked a lot in class extensively that the side length of the box is this length, and this side of this box is that length, and together the area of those boxes together are 36. So I'm going to do kind of the same thing here with my boxes, and we did this in class. If I have a box and I want to know the area of the box, and I see a multiplication problem right here, well, one of my dimensions is this because it's stuff times other stuff. So one dimension, the other dimension. A lot of folks in class said, oh, well, one of my dimensions is x, and my other dimension is x plus x plus x. And then we broke this down into 3 separate boxes so that we could figure out the area of each individual box. So what we came up with in class, at least, was that if I have a box right here, it has dimension, one side is x, the other side is x, and together they develop the value x squared, and then x squared, and then x squared. I'm going to go ahead and do another aside just to kind of remind us of some other things that we've talked about in class, that if I have an area of one box, let's say it's 4, and I have in the area of another box, let's say the area of this is 6, that the total area is taking the areas of each inside and adding them together. So the total area of these two boxes here are going to be 4 plus 6, or 10. Now I know this is a really simple example, but I do that because I want you to see kind of the big concepts that I'm going to bring over. Here, I have 3 small boxes, and they all happen to be x squared. So if I add them together, I'm adding, let's do that. We're doing x squared plus x squared plus x squared, and this is the expanded version. And remember, if we have an expanded version and we're adding them together, if we're adding things together that are the same, the number in front goes up. So here I have x squared plus x squared plus x squared. So in all, I have 3x squares. And we developed this in class. This was a big idea. We will start to use this big idea of multiplying polynomials in this way as we move through this class. There's a lot here. If you still need help, please ask me in class. I am absolutely happy to.